Hi, good morning, my dear students. I'm Daphne Cole. Welcome to my discussions. Today we will discuss about standard enthalpy change of formations. As you recall, all chemical reactions involve a transfer of energy. Chemists call this energy change as enthalpy change of the reactions. Compounds with more negative standard enthalpy change of formations are more stable than their constituent elements under standard conditions, while compounds with more positive standard enthalpy change of formations value are less stable than their constituent element under standard conditions. Therefore, exothermic reactions have a negative enthalpy change, that is, they transfer energy to their surroundings. And endothermic reactions have a positive enthalpy change, that is, they're taking energy from their surroundings. If referring to the STPM syllabus, students should be able to define standard enthalpy change of formations and calculate the value of standard enthalpy change of formations for certain reactions. Therefore, our discussions today will be focused on how to calculate the value of standard enthalpy change of formations for the reactions. Now, let's start to the first part, definitions of standard enthalpy change of formations.
My dear students, to study this topic, you need to put more emphasis on the following definitions. You need or you must remember and memorize all the definitions. I will give you some suggestions how to memorize it. Now, you will ask me why I need to remember the definition first. This is because we use the definitions to write down the thermochemical equations. Now, let me show you why you need to write down the thermochemical equation first. From the data given here, the questions only give the statement about the standard enthalpy change of silver iron, chloride iron, and silver chloride. It doesn't give you any thermochemical equations about the statement. There are three methods to calculate the enthalpy change of the reactions. However, we are only focused on second and the third method. This is because we already discussed about energy cycle in my last lesson. My dear students, we will go to the definitions now. After that, we will come back to these questions again, and I will show you how are you going to use the definitions that you memorize and apply it in these questions. That means how are you going to use the definitions and write out the thermochemical equations. As you recall, we already studied how are we going to use the energy cycle to calculate the enthalpy change of the reactions last lesson. Next, we will go to the definitions of the enthalpy change of the reactions. My dear students, I divided this into three parts. So this is the first part, this is the second part, and this is the third part. We will focus on the standard enthalpy change of formations. However, I will show you how are you going to memorize the standard enthalpy change of formations, combustions, and neutralizations. Always bear in mind that if the definition is under standard conditions, it means it is referred to 1 mole. Now, let's see what is the meaning of 1 mole here. By referring to the work of formations, it means a substance is formed. Therefore, the definitions of the standard enthalpy change of formation as the enthalpy change when 1 mole of the pure compound is formed from its elements under standard conditions. However, some of the students will confuse. They confuse why enthalpy change. Why for the definitions of combustions and neutralizations are heat release but not enthalpy change. So always bear in mind that if the definitions state that enthalpy change means we don't know the reaction is exothermic or endothermic reaction, we need to calculate the value of enthalpy change first. If it is positive, that means it is endothermic reaction. If it is negative, that means it is exothermic reaction. Now, let me show you the summary of the definitions for formations, combustions, and neutralizations. By referring to the work of formations, it means 1 mole of pure substance is formed from its element. Next, by referring to the works of combustions, it means 1 mole of substance is burned completely in excess oxygens. Next, for neutralizations, always bear in mind that if we refer to the neutralization means we will get 1 mole of water molecule. Therefore, we can say that 1 mole of hydrogen ion from acid is neutralized with 1 mole of hydroxide ion from alkaline to form 1 mole of water molecule. For the definitions, you need to tell whether the reaction is enthalpy change or heat release or heat absorbed. Therefore, I put it in this way. For formation is enthalpy change, while combustions and neutralizations are the process with heat released. Lastly, don't forget to put the sentence of under standard conditions in your definitions. Now, let's go back to the questions in example 1. We need to write down the thermochemical equations if we want to use the method of energy cycle. Now, let's see how are we going to use the definitions that you memorized just now to apply in writing thermochemical equations.
Now, let's see how are we going to write down the thermochemical equations by referring to the statement from the questions. So, for the first statement, the standard enthalpy of formations of silver ion. Formations of silver ion. So, what is the meaning of standard enthalpy of formations of silver ion? So, we already memorized it, right? So, it means 1 mole of silver ion is formed. 1 mole of silver ion is formed from its element. So the element for silver ion should be Ag. So this is the definitions for the standard enthalpy of formations from silver ion. 1 mole of silver ion is from its element. Now we have to balance up the thermochemical equations. This is positive 1, while the oxidation number here is 0, this is positive 1. So to balance up the equations, we need to add in electron here. The definitions for the standard enthalpy of formations of chloride ion. So the definitions for the chloride ion should be 1 mole of chloride ion is formed from its element. So the element for chloride ion should be chlorine. Yes. Always remember we put 2 here. This is because halogens are diatomic. So after this, we have to check whether the thermochemical equation balance or not. So 1 chlorine here, but we have 2 here. So how to balance up? We need to put 1 over 2 here. Then we check the oxidation number. For this part, it is negative 1, while the charge over here is equal to 0. It's not balanced. To balance up the equations, we need to put the electron over here. Always remember, we can't put 2 here. We cannot put 2 here. We cannot put 2 here. Why? This is because according to the definitions, 1 mole of product is formed. That's why we can't write like this. No, we can't balance up the equation like this method. Lastly, we go to the definitions for the standard enthalpy of formations for silver chloride. So 1 mole of silver chloride is from its element. So the element should be Ag and chlorine gas. After that, we check whether the thermochemical equation is balanced or not. We have 1 silver here, 1 silver. We have 1 chlorine here, but we have 2 chlorine here. To balance up the equation, we need to put 1 over 2 here. After we write down the thermochemical equation here, we can calculate the standard enthalpy change of formations by using either energy cycle or by using the formula here. So I show you how are you going to use the energy cycle first. From the thermochemical equations, we can draw the energy cycle like this. But before that, you have to know we need to look for the enthalpy change of formations for this reaction. For silver, go to silver ion. For silver, go to silver ion. We need 105 kJ per mole. We need 105 kJ per mole. From chlorine, go to chloride ion. Chlorine, go to chloride ion. We need negative 167 kJ per mole. After this, last one. When silver react with chlorine, we will get silver chloride, and the enthalpy change is negative 127. So, silver react with chlorine, we will get silver chloride. So the enthalpy change should be negative 127. Then by using Hess law, clockwise is equal to anti-clockwise. So lastly, your answer should be like this. Then the standard enthalpy change of formation should be equal to positive 65 kilojoule per mole. Other than using energy cycle, we can use this formula to calculate the enthalpy change of the reaction. From the formula, total standard enthalpy change of formations for the product minus total standard enthalpy change of formations of the reactant. Always remember, only for formations. So what is the meaning of product and reactants here? we need to write down the question first. So this is the questions. The question asks us to look for the enthalpy change of formations for this reaction. So from here, this is the reactant, while these are the product. By referring to the thermochemical equations, the standard enthalpy change of formations for silver chloride should be -127, while the standard enthalpy change of formations for silver ion and chloride ions are 105 and -167. So after this, we will place this value into the formula. We have this.
Next, we go to the second examples. By using the same approach, the first step to answer this question is write down the thermochemical equations. If we want to use the energy cycle method.
Now, let's see how are we going to write down the thermochemical equations for the standard enthalpy change of formations for carbon dioxide, ethane, and water. We look at the first one, carbon dioxide. So according to the definitions, 1 mole of carbon dioxide is formed. So 1 mole of carbon dioxide is formed from its element. So the element should be carbon is solid form, right, with oxygen is gas form. So after this, we check whether it is balanced or not. Carbon, 1 carbon here, 2 oxygens here, 1 carbon here, 2 oxygens here. So it is balanced thermochemical equation. Next, we look at ethane. 1 mole of ethane is formed from its element. So the element should be carbon and hydrogens. H2 is in gas form. After that, we try to balance up the equations. We have 2 carbon here, that's why I put 2 here. Then we have 6 hydrogens here, we put 3 here. Lastly, water molecule. 1 mole of H2O is from its element. So its element should be hydrogens, gas, and oxygens, gas. After that, we try to balance up the equations. We have 2 hydrogens here, 1 oxygens here. We have to put 1/2 to balance up the equations.
Lastly, we use the energy cycle to determine the standard enthalpy change of formations of the reactions. The answer should be -1559 kJ per mole. Other than using the energy cycles, we can use this formula to calculate the standard enthalpy change of the reactions. If we use this method, that means we no need to write down the thermochemical equations. We can replace all the information into the formula. And lastly, we'll get the standard enthalpy change of the reactions is -1559 kJ per mole. Next, by referring to the calculated standard enthalpy change of formations of a reaction, we may determine the stability of a compound. Either it is very stable or it is unstable. If the enthalpy change is negative value, that means it is involved exothermic reactions and the compounds are very stable. If the enthalpy change of the reactions is positive value, that means it is involved endothermic reactions and the compound forms are unstable. Lastly, you have to remember that the standard enthalpy change of formations of pure elements in their standard state is assigned as 0. Here are some examples. That's all for today's discussion. Thanks and have a nice day.